Technology, Manipal. He has 14 years of experience in IT industry, and he has launched strategic management and business planning firm. He has worked on most stages of software development lifecycle and has played roles including management analysis during requirement gathering, prioritizing tasks, design, on-site coordination, coding, implementation, and support. He has managed live streaming applications for TV channels and also OTT. He has handled many sessions as well as a workshop, uh, and also he has handled many client projects. He has handled client projects as machine learning development, smart TV development, Android mobile application, and web application platform. He has honored with various organizations for creating a social awareness, that is Raise Up Game, which was against the dangerous challenge game in the year 2017. He was a mentor and judge. He was a mentor and judge for Smart India Hackathon from 2019 till 2024, which was organized by MIT and NITK, initiated by Government of India. He has conducted more than 80 technical talks within Dakshina Kannada district, that is in various colleges, and also conducted more than 35 plus hands-on workshop for UG students. So with this brief introduction of sir, I welcome you, sir, for this ATAL online FDP, and we are greatly honored to have you for this last session of the ATAL workshop, ATAL FDP. Thank you, sir,
Thank
for
you, ma'am. Thank you so
accepting.
much.
Thank you. Over to you, sir. You can
Yeah.
deliver.
I can share the screen now.
Yes, sir.
Okay.
Yes, sir. It's visible.
Ma'am, my screen is visible?
Visible, sir.
Yes, ma'am. And my audio is also audible, right?
Yes, sir. Audible.
Okay, okay. So good evening, everyone. Welcome you all for the today's online FTP on innovations in smart agriculture, leveraging machine learning, IoT, and security frameworks. So it is my privilege to be a resource person for the 6 days ATAL sponsored online FTP organized by the Department of Artificial Intelligence and Machine Learning, uh, Kendra Engineering College, Mangalore. So today, farms are not just fields where they are becoming very intelligent systems, where it filled with the sensors, then the data, and lots of the predictive models using AI. So the shift from the traditional to the smart agriculture, okay, which is being powered by the technologies like AI, then we have deep learning, then the machine learning, then IoT, and the many other secure digital platforms. Okay, so and that is the focus of my presentation today, which is innovations in smart agriculture. Today, I'll be covering the few topics like major topics like the problems faced by the traditional agriculture practices, then the types of the technology in the smart agriculture, then the evolution of modern agriculture, evolution in the sense the past, present, and the future. The past, in the sense, it's not a very traditional one, but it's where the modern agriculture begins. Okay, where we started using our IoT systems and the basic IoT, maybe from the pilot projects, something like that, where it starts from 2010 till 2024. I assumed it as a past. Then the present 24, 5, and 26 it as a present, and then the future from 2026 to 2035. This is the evolution of the modern agriculture. Then the agriculture startup funding. So suppose if anyone wants to start a business in with like with related to the agriculture field, at that time what are the benefits from the government and what kind of the funding is being received from the state and the central government. So these are my today's topics. Now, coming to the problems faced and causes caused by the traditional agricultural practices. So here, the first one is a low productivity. So we say that the traditional farmers often rely on the manual inspection. Manual inspection in the sense, suppose if they have to, check the disease, so they have to visit each and every places or the plants, leaves, then they have to check it manually. Then which can miss early signs of pest or diseases. So it is very difficult to manage that. There are few experienced, the farmers where they have their own, the execution plans where they identified it. But I'm talking about the in general. So it is very difficult to inspect it, and also due to the misty weathers and those kind of things, again it is very difficult to manage it. Then in the states like the Bihar and Odisha, where the rice and wheat yields are often much lower than in Punjab and Haryana, where modern machinery, high yield seeds, and advanced irrigations are widely used. So here, with the data and analysis which shows that the Punjab and Haryana typically have the higher crop yields for rice and wheat per hectare compared to many eastern states like Bihar and Odisha. Here, in the average rice fields in the part of the Bihar and Odisha is around 2 to 2.5 tons, while in Punjab it can be around 5 to 6 tons. Now, why it is the difference is existing means there are several reasons. Means the in Punjab and Haryana they have the long history of mechanized farming, so they use machineries, the modern machineries like the tractors, maybe the harvesters, which improves the efficiency in the farming. Okay. Then also these states widely, adapt improved seed varieties. So again, it will help you to develop through the agriculture, the agricultural research stations and all these things. Okay. Then we have the irrigation infrastructures. Irrigation infrastructure like the canals or tube wells, where in Punjab and Haryana, which will they are not more dependent on the rainfall, and so this will help them to stabilize the crop growth. So these are the few differences which has been exist. So farmers are often apply fertilizers uniformly and by guesswork. This is the common problems what now like the traditional the farmers what they face. So they apply fertilizers uniformly and by guesswork. Actually, it should not be done like that, but they do that by maybe the wasting resources and the reducing efficiency. Sometimes what happens is in few places where you have the different crops and the different fertilizers has to be applied, but due to the lack of knowledge or due to the miscommunication or maybe some due to some knowledge, what they do is like the uniformly they apply the fertilizer. So this also will waste the resource and also it will reduce the efficiency. So then comes the dependency on weather. So we all know that nowadays, because of the global warming and the weather things, natural weather systems keeps changing. So in it is according to my studies, it is said that like Mangalore will get the long monsoon season. It has already started. Okay, we had already had a large like long monsoons, and the northern areas will get more the heat in the sense like they will be having more summer. So the traditional farming often depends on the natural weather system. Farms in rural North India heavily depend on rain. So unpredictable cycles such as floods and droughts, often lead to very little or no crop yield at all. So here what happens is these crops which are grown overall years can be changed to a seasonal crops. We don't know, because sometimes what happens is in the few areas, so the few crops are like grown or overall years, but it can be changed to seasonal crops. It may be like the monsoon season may be just for 3 months or 2 months, we don't know. So at that time, the farmer should be aware of about all these things due to the change in the temperature. Okay, so this also will disrupt the country's economy and risk its food security. That is also there. Then we all know that India exports the basmati rice and US exports the corn. So again, these everything is depends upon the weather. Now coming to the environmental problems. So planting crops repeatedly without proper crop rotation or planning erodes the soil and depletes its natural nutrients. So here, suppose you take it an example of a corn. So where they need lots of nitrogen, okay, in the soil, and the soil is depleted. Means it has been removed from the nitrogen, which it takes the nitrogen from the soil. So for the corn to grow, it will take the nitrogen, entire nitrogen from the soil now. So after that, suppose if you so the farmer can they can crop the one more crop that is called a soya beans, which has a natural process where the nitrogen, which it takes the nitrogen from the air and it will store in the this nitrogen into the soil. So like this, the crop rotation, the proper crop rotation must be known. So which will helpful for the farmers to to maintain and balance it. Then excessive use of fertilizers and pesticides contribute to the water pollution as these chemicals sweep into nearby rivers through the groundwater channels, ultimately affecting the local system. Again, so when we grow up the plants, we usually some the farmers they apply pesticides and the fertilizers, all these even the chemicals things they will they will apply it. So what happens is when this is near to the water level, okay. So at the time, what happens is when they water or when it rains, the pesticides may go down to the groundwater level and mix with the water. So this may be the problem, and due to this, there are incidents where we have heard the people they have they were drinking some water from the nearby rivers and they got they got health issues, and just because of the some pesticides has been mixed with that. So this also may be the reason. Then the traditional irrigation methods are unchecked and often lead to the overusing of water, which ruins the crops and spoils the soil. Next, the time consumption and the manual labor. So in the traditional farming method, which consumes a lot of time and human effort, so farmers have to manually tend to every crop, then they have to use animals for ploughing, manually check the condition of each plant and calculate how much fertilizer and pesticide to apply to the each crop. So the traditional farming methods, again, they need more human effort. They need the labors. And nowadays we all know that where there are very lots of scarcity of labors in the agriculture field, because most of the people they want to go to city and they want to work, sit in front of the systems and computers, and they have almost of the educated people, okay. So but there are there's the incidents which we have also heard that even from the those who are educated and those who are into entrepreneurships or even in IT field, all these people they left the job and again they have been to started cultivating this kind of crops and harvesting. So this kind of farming also they have started. So that is a one more thing. But now because farmers have spent so much time on manual tasks, they have less time to adopt new techniques, then diversify crops or manage multiple fields, which limits overall productivity and growth potential. Here, I just want to say that one more thing. So the farmers they will spend so much time on the manual task, and sometimes they are not aware of about the new modern technologies or the modern farming methods, and sometimes they think that the traditional method itself they will lead, because since from the past so many years they have used the same method, so they may assume that so this is the only way better way than applying the modern technology, and so that is also one reason where they may not go for that. Okay. Then the precision farming. Now coming to the precision farming. Now these are the problems which we have seen, which the farmers are facing in the traditional method. Now the precision farming means it is being precise to plant's needs. So precision means the being precise to the plant needs. Example, So suppose the traditional farming, they treats the whole field the same, but the precision farming treats different parts of the field differently. So this is the one difference where the traditional farming, it treats the whole field as the same, means whole field. But here, what there may be a little difference with the crops, or there may be a difference between the diseased leaves, or the healthy leaves, or there may be a difference between the soil moistures. There may be a difference, but in a general, the traditional farming, it treats the whole field as the same. But in the precision farming, it treats the different parts of the fields differently. So for that, we use various technologies that we'll see in the later part. So precision farming which is a modern farming technique, which use a technology like, where the sensors, most of the IoT sensors which is being used, or like, the drones are used. Okay, so drones are used. Then we use a GPS system. So the satellite, we access the images through the GPS systems, and or any of the kind of the automations which can be made. Okay, so these are the technologies which has been used. Now, if few soil patch which has got a less nitrogen and few soil patch has a more nitrogen, then farmers, like, they without knowledge, they uniformly distribute the entire fertilizer. Means like more nitrogen. Actually, it is not good, because this will cause the soil patch. So we have, which has been mentioned here. Precision farming is a method of using AI and IoT devices to provide the exact needs of each plant, soil patch, or field section, rather than treating the whole farm like uniformly. So this is the one problem where they are not aware about that. So that's why they will uniformly, they may distribute. So this may lead to the nitric in the soil, which is called that, which is very toxic actually. So this should not be used. Then traditionally farmers inspect the soil and plants manually to decide when to water, fertilize, or the apply pesticides. So the data is being provided for them. Okay, so when to apply the water, and to fertilize it, and to apply the pesticides. Okay, then what the most farmer water, fertilizers, and the pesticides evenly across the entire field, even though not all crops need the same amount of nutrients and water to grow. This wastes a lots of resources and then the time. So this is the one more problem, because as I mentioned it, because uniformly it is been like, it is been provided, because that whatever the the fertilizer which has to be provided only for the particular crops, it has been provided for everywhere, and there which is not required in some places, which is not required. So here a lot of resources and time has been wasted. Then in the precision, yeah. Okay. In the precision farming, the sensory IoT models are used to measure the farm condition, like where the soil moisture, temperature, weather patterns,
For example, a
crop
corn
condition.
sunflower anneke. So that's a good.
Yeah. Any questions?
Like this is good. Yes.
Okay. So in the precision farming, where we have the IoT models are used to measure the farms. Okay. Where we have the soil measures, where we have the soil measures, and then the soil moistures, then the temperature and the weather patterns, crop conditions. So all these things will see now. Okay, because we have the IoT devices, like we will see how these IoT devices is being like used. Before that, we have the data is then fed to AI/ML models to analyze and make decision on the irrigation. So irrigation, fertilization, and then the pest control. So here, irrigation, which is the artificial supply of water to the crops. When suppose if the rainfall is not sufficient at that time, we feed this, like the artificial supply of water. So why this is required? Because first of all, the crops should get enough water. First is that. Then to increase the crop yield. Okay. Then after that, we need, it will allow the multiple cropping seasons. So that's why it has been required. In India, we use the canal irrigation, or as I mentioned, there tube wells and the bore wells. Mostly it is used in Uttar Pradesh, and the canal wells also, which is used in Punjab and this Haryana. Then the drip irrigation or the sprinkler. So these kind of irrigations which we have used. Then comes the fertilization, means it is a process of adding nutrients to the soil, where we improve the soil fertility and the crop growth. So for that, the fertilization, that means the fertilization. So this is required where the soil, when the soil loses the nutrients after repeated farming, that time this fertilization is required. Then fertilizers will also restore the essential nutrients, like we had the nitrogen or the potassium. So these kind of nutrients, it will restore it. So that is why it is required. So example again, the urea, which is used in the wheat fields. Okay, then organic manure, which is used in the Sikkim. So these are the few examples, which fertilizer which is used in India. Then we have the pest control. So the pest control, which means the protecting the crops from crops from the insects, or what do you call the fungi or diseases, which will damage our crops, the farmers' crops. So for that, the farmers use the pest control. So it is required to prevent the crop loss first of all, then to improve the quality of the crops. So that's why it is required. Again, under that we have different types, which is called as like the chemical, which is the pesticides and all. Then biological, we have some natural biological things. Then after that, then we have a mechanical also, where a manual removal are the traps and all those things which is being used. So any example is like in Maharashtra. So they spray pesticides in cotton fields, okay, to kill that worm. So that is one more example here. We can see here the precision farming uses the GPS technology, okay, where we have the satellite GPS at the top, and the satellite GPS will send the signal GPS which is being received to the base. Once it received to the base, then the signal, which is been sent to the automated the tracker, which is been automatically, which has been controlled. Then using that, the pesticides and the chemicals are precisely given to the crops, individual needs. You can see the color. See now, suppose if you can look into the color over there. So suppose the gray area, it can be considered as like where there is a less moisture. Okay, less more the soil moisture, and one more place like the green, maybe like with the where we had a proper soil moisture. So it has to whenever it has to apply some pesticides and the chemical, it has to apply only for that particular region and not uniformly distributed. So these kind of automated systems, where the GPS, it receives the GPS details, GPS in the sense, and from the top it has been divided. The entire area is being divided, and this area, it is not just for a single farmer. Okay, it is not for a single farmer. It can contain a city, maybe multiple farmers there. Again, it may contain the districts, or it is states, or the whole countries. Okay, so this is the one example here. So this is a type of technology in the smart agriculture what we use here. Then we have the remote sensing, of crop health monitoring here. So now here we have the high resolution cameras fixed into the drones, which capture the crop color, canopy cover, and then we have the growth patterns, all these things on a large scale. So this enables the AI system to collect the data over all the crops present on the farm. So this means camera, camera which has been fixed in the drone. So which has been fixed in the drone. So that is been flying high, and it will capture few photos. Means it is equipped with the high quality cameras. Okay, and a detailed images of crops is being clicked. So then these kind of images, which is been then analyzed, where we have to understand the health, growth, and the condition of the plants, maybe across the entire field. So the drone can cover a small part, where the GPS that can cover the whole entire country. Okay, so and since the drone have a limitations, so here we can see again the drone use the advantages of the drone, where which avoid the chemical overuse.
Asta open asta. Asta. Arsha edte asta. Ama yaad uchka.
Participants, please
Mane.
mute your mic.
ಕೈ ಮಾಡ್ತಾಮ ನಿಮ್ಗಿಲ್ವ ಕಾಸ್ಟ್ ಶೀಟರ್ ಕೈ 171 ಮಾತ್ರ ಸಚಿ ಅಟೆಂಡೆನ್ಸ್ 330 ತಾನಿ
Kindly mute your mic. Sir, you can continue. Sir, I think you are muted.
Hello, ma'am. Is it? Hello, ma'am.
Yes, sir. Now it's audible.
Okay, my weather glitches. Have you heard, ma'am?
Yes, sir.
Okay, I'll repeat that. Ma'am. Sorry, I'll repeat that. I was not aware of it. Okay. So in the weather glitches, so prepare for the weather glitches at that time. If the drones are flying high, where it can sense the atmospheric pressure. So when it drones fly high, at that time, high atmospheric pressure means like it can detect the storm or the humidity or the water vapor. So when there is a water vapor, it is understood that it may rain right now. So that data can be sent to the farmer, and he don't have to now he has to apply any water or anything like that at that particular moment. So this has been already been understood. Okay, so that is the use of that. And then again the crop spraying. Okay, where the drones will spray the pesticides and the fertilizers precisely. Again, not for the entire farm. So suppose if it flies in a particular area, maybe we calculate with the square feet or the square meters. Again, the drones will spray the pesticide and the fertilizer precisely in that particular area. So it will reduce the chemical exposure to the farmers and saves time. Again, for the human, again the chemical exposure is also very dangerous. So that is also one benefit from this drone. Then we have the geofencing. Okay, so geofencing means like an artificial border around the regions. Artificial border in the sense of digital border. So it takes a picture of one photo, and after that it will provide. One second, let me. Okay. So here you can see that the thermal view from the satellite. This is for the satellite. The similar way like that. So what we can do is the artificial border can be it can be applied for the particular region. So suppose if it is one 5-acre land. So 1 acre land is being divided now because the geofencing automatically it will detect that there is a green area. So it is like related to some crop, and one more one more area, 2 acres maybe divided into one more crop. So like that it can divide it. Okay, so this is a geofencing. Then we have the crop monitoring. So the crop monitoring where it will capture the aerial images means regularly. Where early detection of the stress, disease, or the nutrient deficiency for the plants or the crops. So that will be monitoring. Then monitor growth. So monitor growth means again track the plant height and the canopy development the over time. So it means this will help the predict of to the yield and growth stages of each and every plants. So we get a dashboard kind of thing where we get information or like the visualization in a sense like where we have the graph section. It explains actually over the period of time how the plant is been grown. So from the initial stage, so after maybe 2 months, 3 months. So since every day the drone is been captured, so every day's growth is been like shown to us. So that's called a monitor growth help. Then the plantation. Okay, then we have the plantation. So what happens is some drones, they drop the seeds or for the particular area or like seedlings and all. So for the first plantation in a large or like where what do you say, the inaccessible areas which where we have. So to have the fast plantation, we use this. Okay. So then comes the soil and the field analysis. So here it will analyze the soil moisture, then the erosion and the field variations, where it supports the precision irrigation and the fertilization. Again, the soil and the field analysis means the precision. Again, precision is very important, and the which supports the irrigation and the fertilization. Suppose a dry patches which has been detected in a white field. So this has been analyzed now. Dry patches, once it has been detected, it has been detected. What is the reason for that? And then we can take some preventions based on that. Then we have the livestock management. Means this is about tracking the animals like cattle, location and the movements. So for that we tie some bands maybe on the neck or a leg somewhere. We tie it and like then we track it. So this one will be helpful. Suppose if the animals where they pass the border. So we have some geofencing borders. So we suppose if they move out of the border or like if any theft happens, so all these things like it will be helpful for us to monitor it. Okay. So for example, like the sheep monitoring in a large farm, like using a drones, that even that can be used there. Then check crop health. Crop health, we use some cameras to calculate, that is called a normalized difference vegetation index is there. We call it as a NDVI. So even that has been calculated. Means benefit is like to identify the early disease of the plant or the stress detection. Suppose if any such things are there, so identifying the initial stage. This is like NDVI is like it is a metric which measures the like vegetation greenness and health by analyzing light reflections, whether it is a red and near infrared, which we call it as a NIR spectrum. Okay, and it will give some indicate some value which ranges from the -1 to +1. Means +1 means the dense vegetation, -1 means like the water or something like that. So this is about the check crop health. Now coming back to the previous slide, where this is related to the drones. Okay, then we have the hyperspectral imaginary and the 3D laser scanning and thermal imagery using satellites in orbits and which are capable of rapidly providing enhanced information and plants metrics over the thousand of acres of land. So this is the one related to about the satellite one. This one, yeah. So the thermal view. So this is a thermal view from the satellite in the orbit. You can see here where we have the Sentinel-2 satellite, Sentinel-2 satellite, which is used to inform the farmer. So what happens here is the area is being divided now. So since it is a GPS satellite images, so the area is been divided and you can see there green, which may be like good like indication, or suppose if it is a red means if it is a we consider it as a bad or a negative. So something like that. So when we have this particular kind of a image, this image has been sent to for the data analyst, where they analyze this data and they perform some action based on some the requirement. So here you can just observe here in this image Sentinel-2, where we was for the spatial images and the temporal, the timeline information detection, which will be sent through the AI, which gets the AI will process it, and that will send to the ministry. Actually, this is from the European Union. Actually, the image is a reference from them. So where the European Union will the capture the photo of the entire area, then using AI processing, it will send that to the ministry, means the agriculture ministry. Then after that, based on that, the decision is being made by the agricultural management. So based on that, we have the plant psychological status and physical composition monitoring can be done. So this is using this one, the Sentinel-2 satellite. Using Sentinel-2 satellite, we can use this. And these satellites, orbiting the Earth, use advanced sensors where they collect very detailed data about the crops, like the plant health, height, then the growth condition, and it is across the very large farm areas. This has been collected. Okay, then these are the the spacecraft that continuously move around the Earth, and it will observe the surface. So they monitor this form regularly. It may be daily or weekly. Again, that depends. So, but it monitor the forms regularly. So, and it will cover the very large areas. As I mentioned that time, it may cover the district, the city, the states or the countries. Again, then again, the hyperspectral imaging, which means that it captures the light reflected from the plants, means in hundreds of very narrow wavelength bands, not just a red, green, and blue. So that's why, when you see the output, you get a different colors, which is been displayed, and this lights which has been mentioned, which has been shown, right? It depends upon the health, the water content, or maybe a nutrient levels, or the disease or the stress. As I shown that in that image, I explained that consider the green maybe healthy. Okay, maybe the red color it is not healthy or bad. So this kind of data is being sent. Okay, so sent to the data analyst. Then we have the 3D laser scanning and the thermal imagery. So this is a light detection and the ranging, which sends the laser pulses from the satellite to the Earth, and it will measure how long they take to return. Okay, so that's why once if it has been emitted and how long it will take to return. So based on this, it is you can calculate the crop height, canopy structure, biomass estimation, and the terrain shape. All these things can be calculated within that. Okay, so then the data is then used to the predict disease, crop decay, drought stress, pest damage, or poor soil health before they are visible to the naked eye, which I mentioned already. Okay, so these analysis can be conducted frequently and efficiently. So again, this analysis is there again. It depends. So it can be conducted the frequently and efficiently, and it may be a daily process. It may be a daily process, and in the nowadays instant data can be picked, and it can be displayed immediately. Suppose if it is a raining or not, or any related from the IoT sensors, what are the data which has been analyzed, so that can be sent instantly and the farmer can view it instantly. Okay, then traditionally a farmer had to check each plant manually and carefully, often to diagnose potential problem. This often led to the false diagnosis due to the insufficient knowledge. This I hope we already I have already explained this one. That's a traditional where he has to check the plant manually. So as a solution, we have all these remote sensing and the drones and other satellite help, where we take that and we use this modern technologies, and then we give this feed to the AI. Then AI does the work, it process, and it will predict and will give the results. Then we have the automatic, the irrigation systems, where the recent decade, IoTs of the farmers across India and the rest of the world use automatic irrigation system. So suppose if you have heard about the Israel. Israel is one of the country where very recently, very early, and very earlier stages, they started this irrigation system. So this uses the sensor-based watering. That is, before water is supplied to the crop, each factor like the soil, moisture, means if soil is ideally wet, okay, then no need to water it. If it is a dry, then water it. So these are the sensors based on the sensor watering. So we can identify. Then again, the temperature. So if it is too little, like the freezing state, then applying water will spoil the plants. It may freeze. It may with a very cold regions. So that should not be done. So all these things. So the basic things, and the humidity which has been detected. So this data is next sent to the AI model. So we have a trained model. AI has got a trained model. So the trained model, so this data is been sent, okay, which analyzes the census data along with the weather forecast and crop types to provide the precise amount of water required to optimally cultivate each crop. Then the sensor, which has been analyzed, then it will tell you like what is the precise amount of water required to cultivate the each crop. So then this data is then fed to the IoT enabled sprinkler that use the received instruction to automatically supply the crops with the ideal amount of water. Suppose if the soil is dry, then now the signal is being sent to the IoT. So what happens is IoT automatically it will enable the sprinklers, and then it will the water is being feeded to the plants. Then this prevents over irrigation, reducing water usage and avoiding the soil nutrient loss. So here you can observe there is a input, the soil moisture sensor. We have the soil moisture sensor, and then we have the AI processing unit, the crop water calculations. So then the output is the smart water system. Okay. So here what happens is, in this stage, the sensor will sense, which is kept inside the soil. So it will give that's the input actually. So when the input is being taken, then the AI processing, the unit, it will calculate the crop water calculation. So once that is being calculated, then the data which is being sent to the or the signal which has been sent, then it will start sprinkling. The IoT device it will start sprinkling, and then through the sprinkler the water is being fed. So that's called a smart water system. Then we have the agricultural robots. We have agricultural robots where it will help the cut down the manual effort and save time by performing multiple tasks on the farms. So here we have the tractor robots where they collect the grains from the field and then store it in some storage unit. Then it is been unloaded to the designated area. Designated area may be some one more truck, or maybe some the what do you call the some godowns or somewhere. Okay, so this tractor robots will collect the grains, and as an example, and from the field and store it in some storage unit. Then it unloads to the designated area. So the driver, then these tractors also used to sow seeds and pluck weeds. So it can be used for both the ways. You can just see this image. The driverless tractors, you can see here, where the grains from the field, which is being harvested. Okay. Then FF robotics fruit harvesters, fruit harvester, it will pluck the fruit, and again it can be divided. So suppose it will filter the ripe fruit one side and unripe fruit one side. Maybe for the manual purpose, unripe fruits also sometimes it may be required, and stores in the respective containers. So till there, we have the particular robotic structure. And the companies like Agrobot and the FF Robotics, again, this is from the European Union, from these countries, the companies have developed the special fruit harvesting robots that are used to detect grown and ripe fruits, ensuring only the best fruits are selected and the damaged or the unripe ones are discarded. Then AI-powered smart greenhouse. So here, the farming across the world is now threatened, because of the global warming and the climate change. So we all know that there is a global warming, the threat. And as I explained there, just an example of our city now, the South India, where we get now more rains, where more rains we get. That means it has been changing. Usually we had it has been divided summer, winter, and the rainy season. But this time the coastal areas, this time they got more rainy season. Maybe it extended for 6 to 7 months. So it's already crossed it. So these are the few threats actually which we are facing again. And again, which will cause higher average temperature, than the heat waves, irregular rainfalls, all these things are there. For that, the solution is the smart greenhouse, a novel solution to this problem, which is simulating an ideal environment for the crops to grow in. In this situation, what we have to do? Because suppose if it is a more rain, suppose when here in the coastal areas we grow, the rice, the more rains means in the sense like the crop will be destroyed. At that time, what we have to do is we have to create an ideal environment for the crops to grow in. So that is called a smart greenhouse, which is controlled farming environment where like the temperature, humidity, the light, water, which is automatically monitored and adjusted, where we use AI, IoT sensor, and then the automations. You can see here. This is one example where the smart greenhouse, where we have the IoT nodes. At the top, we have the IoT nodes, and we have a base station below. Okay, that is the computer system or the server which monitors everything. So based on that IoT nodes, where below we have the soil moisture sensor, the input based on that particular input, we can monitor the air condition. So you keep this the climate like in this particular cooler, maybe very cooler. Suppose if that is required up to 10 degree or 12 degrees, so then we have to monitor that. So that will be monitored by the temperature sensor again over there. Again, we have a higher sensor for all these things where we can monitor the soil like moisture sensors. So the entire the setup, this is called a one smart greenhouse. And here the role of the AI is to learn optimal conditions for each crop, then by analyzing the sensor data continuously. So whenever we receive the data, so it has to analyze continuously. Then it has to predict the plant stress or the disease. So this is the one more thing with the AI, which is helpful. Then automatically adjust any of the systems. Automatically adjust any of the systems. So you don't have to get the information. So automatically you adjust according to that. Okay, then we have a role of the IoT sensors where it will detect the temperatures, and it has to manage the humidity sensors, then soil moistures, then the light sensors. So all these data which is been collected, it is sent to the AI, that is for to make the decision making. Okay, so that for that it has been required. Then the IoT technologies like the smart sprinklers, then humidifiers, and temperature and humidity sensors, soil moisture sensors, and the automated fans and the LED grow lights. Again, LED grow lights where uh, it can uh, it can provide the light. It can provide the light. Suppose if I want to have so the sunlight again it changes. Means it depends upon the region to region. So suppose if I want to have the particular condition, maybe how it is like in Kashmir. So the same thing, the setups of using this all these things, with the temperature sensors and automated fans and LED grow lights, we can create such a the microclimate which is as close to ideal which is possible. Okay. And in this one thing where the soil moisture sensors, okay, so what it does is that it will measure how much water is present in the soil. Okay, 1 second, let me explain this sensor. Yes, the soil moisture sensors, okay, where it measures how much water is present in the soil. So this is what it is work, and helps decide when and how much the farmer it has to irrigate. So it will help decide when and how it is to irrigate. So example like in a drip irrigation system, like irrigation turns on only when the soil becomes dry. This automatically it can be made. So since the advanced the technology has been advanced, so it can be automated again. Then we have a soil nutrient and the pH sensors, where it measures the nutrient levels, as I mentioned that nitrogen, the potassium and these things, and acidity of the soil. So it will measure the nutrient levels as well as the acidity level of the soil. Uh, so suppose if a farmer in Punjab uses a soil, sensors to apply urea only where nitrogen is low. So that is why this has been required. This is required. Next, weather stations. So it will measure the temperature, then the humidity, then the rainfall, then the wind speed, and the solar radiations. Okay, so it predicts the irrigation, like what it needs. Then it will identify the risk and then the disease outbreaks. So this is the weather stations, why it has been used. Then we have the greenhouse sensors. Greenhouse sensors which will monitor the internal temperatures, then the humidities and the light inside the greenhouse. So since it is being managed, it's like a package which is being kept within a few square feet or square meters, what we can say. So the greenhouse sensor, so it will do all the related, work what I mentioned above, but within the internal temperature, not the outside. Okay, so it maintains a very optimal climate for the plants. Then we have the drones. We have already discussed. That is about the capturing the images of the fields. Then it divides it. Then it will detect the crop, the stress, then pest attacks, and all these things. Then automatic crop harvesters. Here, it harvests crops automatically using machines and AI. Okay, and it reduces the labor cost and speeds up harvesting. This also we already saw that, like, the tracker robots automatically it will harvest. And we also seen, like, two companies from the European Unions where which is very famous in the agriculture, and most of the people they are using the same technologies. Then we have the smart sprinklers. Okay, the smart sprinkler which automatically controls the water flow now based on the soil's moisture or a weather data. So what happens is, here the IoT sensors, it will send the data. Suppose if it is dry, the soil is dry, it will automatically will send the data. Then based on this, it invokes. It executes, it works. So that means, like, it automatically controls the water flow based on the soil moisture, and also obviously with the inputs which it is been received. So it uses it saves water and prevents over irrigation. Then we have the automatic feeders. So what happens is, when we have the animals like cattle and other animals, so it dispenses food automatically to the animals or to any of the poultry. So again, there it can be scheduled. Maybe morning this particular time, so you have to feed them. So again, after 2 hours or 3 hours, again you have to feed them. There may be a same food to feed, or there may be some different foods. So everything is been automated. Otherwise, manually, the farmers, or anyone, the human, they have to manually, they have to go to that particular place, and then they have to feed that. So it ensures the proper nutrition, and also the reduces the manual labor. Then we have the grain analyzer. Okay, Grain analyzer is nothing but it will check the grain quality, whether the moisture content, then the size, then impurities, all these things are there. So once it input the grains, and then it will analyze the properties, maybe the qualities of the grains, then the value of the grains, and it has got a different containers. So it will put that into the different containers. So these are the common IoT devices which is used in the agriculture. Now, coming to the livestock monitoring, to track and monitoring animals, where AI and IoT is used to monitor and track farm animals. So, as I mentioned earlier, so they tie some a band to the neck or to the legs anywhere, which is variable IoT sensors, and you can track the animals' heart rate, transmit their location to the owners. Again, for the health issues, suppose it is better to prevent it. Suppose if it gets disease, so it is better to prevent it beforehand. So that's why that has been required. And these data are sent to the AI model, which then tracks and records and predicts the animal health. So it's potential diseases and mating cycles for a poultry, and for the egg laying cycles. So for that, this has been managed. So that the owners can take care of their animals. So here you can observe where the variable IoT collar collects information on the animals biometrics. One is at the neck and one is at the leg, and it transmitted to the computer. So there's a gateway to the Wi-Fi, and from there it will reach to the cloud, and then the owner can view the data. Again, it can be visualized. So he can see the past data. So a past month, how was the heart rate, or like any of the other informations, and how is it the present, and also it can predict. It can give some information saying that based on this, now this cattle may get some in a disease. The AI can also predict here. So the farmer can also track the animal's location on their devices. So that suppose if it is a forest area, so it should not cross the border or should not go inside the forest. So because of the wild animals attack or something like that. So to secure them. So again, there we can use this kind of a technology here. Now, this is the problem scenario, okay, where we have the AI and the machine learning in agriculture, how it can be used. I just took one small problem scenario where it plays an important role, both plays an important role in a modern agriculture. So they can analyze agriculture data, identify patterns, and support intelligent decision making. So that is again very important here. Okay. So AI-based systems which helps the farmers in crop monitoring, disease identification, and improving productivity. We take a small example that is called a smart agriculture, where we can see in the picture where we have a drone, where we click some picture of the entire field, and how do we analyze that? Suppose if we do a small project on this, okay. So now farmers often face difficulty in identifying crop disease at an earlier stage. So this is the problem scenario. So that's manual inspection of the crops. It is time consuming and requires expert knowledge. Okay. So the late detection of diseases leads to the reduced crop yield and financial loss. You can see one is a healthy leaf and one more is a diseased leaf. So it is very difficult for the farmer to identify. Means in a field where you have got lots of acres of a land. So it is very difficult to do that. So that's why identifying whether the crop leaf is healthy or diseased using images. So what we do is we use this images. Now we have the drone image which is been clicked, and which we input that. Okay. So before that, what we do is we have something called the trained data. So using we collect the data set in the sense it's a collection of images. So assume that I have one 50,000 images of this particular plant, and it contains 25,000 healthy, 25,000 not healthy. Means it's like a predefined. I'm not talking about the particular farm there in the field which the drone has been taken. I'm not talking about that. It is previously. Before that, we have this particular data we call it as a data set. It's called an image data set. So we have a 50,000 data set, and that has been trained. Now we get this data from the Kaggle or the OpenML, RoboFlow, or the Google data search research. We have a different sources. From there we can collect this data. Okay, then we build this application. Means we train this model. So data set characteristics, images of healthy and diseased leaves, and labeled data for supervised learning. So what I do is I label it for all the 25,000 images. I label that this is healthy. And for other 25,000 images, I say that this is a diseased label. So now 25,000 is healthy, 25,000 is diseased. Total, I have a 50,000, the images. So now this data set acts as a input for the training the ML model. So now how this model is being trained. Now the raw agriculture data cannot be directly used for a training. So data pre-processing is required to improve the model performance. So what we do is, again, see now we have the picture of the drone which has been clicked, but we cannot use that. What we have to do is, first we have to pre-process it. The whatever the image which has been clicked by the drone, that has to be pre-processed. And what are the steps actually? In that we have a image resizing, the pixel normalization, noise removal, then we have the data augmentation, which is called a rotation and flipping. Now image resizing means where the leaf images are resized to a fixed dimension so that all the images get a same size. You can see the first one, the raw images, 100 pixels and a 64 pixels. Okay, so that which is been like the resizing. It has to be resized. Then we have a pixel normalization, where the pixel values of a leaf images are scaled to standard range. This improves the learning speed and stabilizes the training process. Okay, the second one. Then we have the noise removal. Suppose if you have any unwanted distortion, like the image which is being taken by the drone, which is blur, okay, or we have a shadow in that, or any background noise in the leaf images, then we have to remove the noise actually. Otherwise, we have to ask for the new images. So these pre-processing steps are very important. Then we have a data augmentation where the leaf images are rotated or the flipped to the create additional the training samples. So once these steps are being completed, then it will reduce the errors and to improve accuracy. So why we did all these things to improve the accuracy? So what I'm doing is I'm explaining you how the AI process is working. Once you click the images, what are the pre-processing which has been done? After that itself, you get the proper accuracy. Now, the data set is divided in two parts, maybe 70%, 75% training data set, where it is used to train the model. As I mentioned, the trained model is like from the 50,000 images. Then we have the testing data, which is used to evaluate performance. Now, I'm providing my testing data, the drone images. So those are called testing data. So for this one we use the CNN algorithms. Okay, for the image processing we use a CNN algorithm. So using a CNN architecture, what we can do is we can uh, reduce the error and where we can improve the accuracy of this particular the output. So the output whatever you get more accuracy. So you can observe here where we have the convolution layer in the CNN architecture, which will find the important feature in the images like edges, shapes, and disease spots. So it will identify that. In the pooling layer, in the second layer, which will reduces the size of the image to make the model faster, and it will avoid any of the overfitting things. Then we have the dense layer, where it uses this feature to decide the final class, whether it is a healthy or diseased, because we already labeled it. Okay, so at the end of the layer, we get the output whether it is a healthy or whether it is a diseased. Okay. So after training the model, okay, we get the output. So you can see the epochs where we have till 10. Then you can see the accuracy, and the data loss is less actually. So you can see the data loss. So which is a common evaluation metrics where the accuracy measures correctness of the prediction. Then we have the loss, which is like measuring the error during the learning. So that loss should be very less. So that means where we can reach the high accuracy and the low loss indicate, which effective learning. And we have the epochs, you can see there below. Epochs in the sense like, if you have around, assume that you have 1 lakh images. So one epoch means the model sees all 1 lakh images once. Means my training model, it will see all the 1 lakh images at the once. But training for 10 epochs means the model see the same images 10 times. So 10 times means like 10 times it has been evaluated. Okay, so one thing is like the advantage is like you will get a very better accuracy, but the one again we have a disadvantage means more time is been consumed or the more CPU usages are more. So what happens is after each batch the model will update its weights to reduce the error. So that is why this is been used here. So after model evaluation, the trained machine model is deployed using web framework to make it accessible to user. This is like see whenever we have that AI application. Okay, so there should be something like the interface for the users to view that. Now the owner of the viewer, he has to view. Suppose if Google Chrome or Firefox, at least he can browse it and he has to view that. That is the interface. Where the interface is like created within that particular browser. So that's why we create some web frameworks. Okay, so where they can see the real-time plant disease prediction and the leaf image upload through web interface where the owner can upload. He can upload the images and he can manually check that a clear display of the prediction results, and he will get the prediction results. So this can be the output where the AI powered plan disease prediction, and how it works is being displayed. This is like another web framework, the output. And in the second image, you can see where the user can upload the images and he can analyze the leaf, and you will get the result. It's a healthy leaf or the disease leaf. So suppose if you want to see the clear result, you can see there the no sign of disease detected and the leaf is healthy. So this is like analyzing. So you can analyze one more leaf. So this is the one process. Then we have the evolution and the key innovation. Okay, so as I mentioned earlier, so that I have divided this slide into different, the past, present, and then the future. So in the earlier stages, or means in the modern agriculture, how this was been implemented. The IoT and AI is been implemented in the agriculture. Okay, so that has been mentioned here. So in the earlier stages, 2010 to 2015, it is involved isolated research technologies like sensor-based monitoring system and IoT in precision farming were being implemented in few developing countries, where the Israel and US. So in Israel, it started initially the precision farming, where they started, and they started exporting agriculture, the products to all over the countries. This is the initial stage. And so the implementation of AI and IoT in agriculture was limited because before 2019 till, because of the high cost and the complex technologies, and only the research only usage, because only the research only could have been told, like either it can be implemented or not. So it is a waste of time. So a few people might have thought, and they didn't implement it initially. Okay. So then later stage 2010 to 2015. So there it focused on isolated research, where the pilot projects which has been created, where only the prototype has been created, the initial prototype. So it has been said, like suppose if you can develop something like this, and we can get some kind of output like that. So this has been mentioned earlier. So at that time, the sensor based monitoring system, then early IoT based precision farming was introduced in the year in that 2010 and in 2015. Okay, as I mentioned, Israel used the soil moisture sensor for the efficient irrigation at that particular timing, and even the USA, well, it was testing the GPS based at that time precision farming. It used to try that time. Okay, then 2016 to 19, where with accelerated growth in tech industry, research gained monuments, leading to innovations in low power IoT device and cloud computing, enabling more practical applications, where case studies began emerging, such as Microsoft's AI initiative in India, which demonstrated a notable increase in the crop yields. Okay, here, which means that growth in the tech industry accelerated agricultural innovation now. So low power IoT devices, where IoT device became very cheaper, and it would have been for even for 2000 or 3000 rupees, we used to get this soil moisture sensing and all those things, and even for a cheaper rate we used to get that. So cloud computing for data storage and analysis, for each and everything it is being used at that time. Then widespread adoption and innovation from 2020 to 2024. So this is considered as a golden age of the smart agriculture or the smart farming, because here the rapid growth happened, where in the both research and the real world in the sense the implementation, even the research it is to take place simultaneously, and in the real world implementation also used to happen. So means that they could see the result as output. Then AI and the IoT technologies became very cheaper and more accessible and easier to use, more than that. Okay. So then the developing countries, like India and in other countries, even they started adopting smart farming. So this is the one more changes which happened here. Okay. And the key innovations, again, the precision farming, automation and robotics, drones and remote sensing, smart greenhouses, and the livestock management, predictive analysis, all these things are started. And the countries, most of them, that involved is one is India, where the smart irrigation and AI advisory platforms and drones which has been implemented in India. Then in Brazil also, the precision farming and automated machineries and this remote sensing, all these things, modern technologies, they started implementing. Then in Indonesia, where the drone monitoring, IoT sensor, AI-based crop analysis also, they started implementing that. And this is the images of this, where the smart greenhouse using smart hoses to apply the pesticides, then animals wearing IoT collars to track them, then the drones being used to spread the pesticides. Now the evolution and the key innovations. Here in the 2010-2024, graph shows the amount of research articles published on the smart agriculture from the 1980 to 2020. So till 2010, it was up to that one particular level, but there was a rapid change from from 2010 from there till 2024, and now still it has been modified and it has been changing, right? Then we have now 2025 to 2026, that is called a present. At present, we use a precision resource management, means IoT sensor, monitor soil moisture and nutrient levels. These things are implemented everywhere. And AI analyzed data, where we can automate the irrigation and then the fertilization, even that has been implemented. And then reduced water and fertilizer used by the lowering cost. So that is been implemented in this stage. Means that I'm talking about the present situation. Then we have the AI based pest and disease management. Again, we analyze the drones and satellite imagery through the computer visions. Then it will detect the early signs of the pest and disease. Okay, so those things. Then automated farming. So the GPS, it enabled the tractors and robotic system optimize planting, spraying, and harvesting roots, boosting efficiency. Where the automatic farming could be done in the first, the image which I showed there, the way the GPS will track the robot, the tractors. Okay, so GPS will, manage that. Okay, so it will send the information to the base station, where that will control these particular tractors. So it has to move to which location, and suppose if I have to apply any pesticides, it has to apply in that particular location there. So that's one. Then we have the enhanced remote sensing. Okay, remote sensing, where this is like using drone and satellite. This is integrated with the GIS for the precise mapping, where we can receive high definition multispectral thermal imaging. Okay, so thermal imaging from the drones, we're identifying water stressed crops across hundreds of acres. So this is called the remote sensing. So and based on that, like detailed analysis of the crops, soils, and other factors where which can be identified. Then we have the predictive analysis, where AI analyzes the large data sets, maybe the weather, soil, and the crop imagery to predict, the crop yields, then disease, outbreaks, then climate related risks. So all these things, and this will support, the better farm, decision making. So that's why this is required. That's why it said that guide farm management decisions. Then we have the sustainability focus, where smart agriculture ensures no resources are wasted. Okay. Then this supports, the regenerative agriculture, where we can improve the soil health, then the climate resilience. So all these things can be managed using the sustainability focus. Then the future focus in the coming years, where in the next generation, where the sensors and decentralized AI using a blockchain. And it is very important for the data theft, or like for the data leakage, for the security purpose. So decentralized AI and the clearer policy for ethical AI implementation will pave a path to the booming agriculture sector in the multiple nations. So this is the future, the focus. Now, this is the upcoming in the coming years, where the agriculture will be transformed with the integration of more smarter AI, models, better and more advanced IoT devices. So the integration of the smarter IoT AI models or the advanced IoT devices, which is not being built till now, so that it may come in the future. And the outcomes may be the higher efficiency and optimized resource usage, and the less labor can be used. So all these things may be the advantage of these things. Okay. Then here we have the precision agriculture dominance, where we have the system that uses a data-driven calculation to analyze and manage crops at a micro level is projected to be major market driver, where this can be optimized the water level, fertilizers, and the pesticides, where up to 60% of the reduction in input usage and the 15 to 30% increase in yields. It means you using this kind of the modern technology, it may increase with that. Okay. And the advanced IoT sensor networks provide, again, real-time local data in instant record data. Instant record data can be immediately, which can be seen by the owner immediately. Then we have the hyper local monitoring and the data monitoring and analytics, where IoT sensor networks integrated with the AI technology will become more advanced and reliable, providing quick real-time hyper-local data on soil moisture, then nutrient levels, temperature, and the crop health, where the AI algorithms will process vast data to accurately make insights and predictions for optimal planting, irrigation, and harvesting time. Here, the local monitoring and analytics means where we have, where the big data, which we can say, where lots of data which has been provided for the training model. So once the model becomes like more trained, at that time it can give the very good accuracy, and the output will be very realistic. So that's why this has been used, and the increased use of the driverless tractors, the laser weeding robots, and the precision harvesting the systems. So that can be the future advanced automation, and about the robotics. So the means like we may use the driverless tractors, laser weeding robots, and the precision harvesting systems here. And the benefit of this is reduced labor cost, then the solution to the labor shortages. So this so since we all know that like the country like India, where we have got lots of labor problems for the agriculture, not for the other things, but for the labor, for the agriculture, we have the problems. I think so we can reduce that labor cost using this one. Okay. Then the automation and the robotics example can be the laser weeding robots, where which removes the weeds without using a chemical herbicides. So that can be one of the examples. Or the driverless tractors, where they are operating continuously to reduce the labor dependency. So once if you give the signal, or if you can inform it, and since it is works like a robot, automatically it does all the other works. Okay. Then climate smart and sustainable practices. So the climate change is a global problem that everyone knows that, and it will affect all the countries, especially countries like India, which are located near the equator. So this will accelerate the adoption of the sustainable practices. AI and IoT will be the central. So we have the optimizing water usage to the through smart irrigation system, then reducing the chemical inputs, then enabling carbon farming and regenerative agriculture practice, which focuses on improving soil health and sequestering the carbon. So all these things can be the made over that. Then smart irrigation system, where reduces the water usage during the drought season in India. So this can be the one example for the sustainable practices. Then we have the supply chain. So in the supply chain and the traceability, again, just now what we have seen from the the seeding a plant. Okay, from there it starts actually the entire growth, which can be captured through the through the GPS or through the drones. So the entire growth is there, right? That the supply chain, and the harvesting. Once it grows, then when it has been harvested through some of the tractors and it has been kept in some other place. So entire supply chain integration and the traceability becomes very much easier. So there you don't have that black dots where we can see that the crops I had this much crops and it has been like the crop theft or some other problems. So that can be such things can be reduced actually over there. Okay. Then we have the digital twins in the sense like the simulation kind of things. So what we do is like we can provide a simulation for the farmer, the virtual simulation, and that's like a virtual farming environment where the farmers will be enabled to simulate with the different scenarios like how to grow the crops and how to get this data. Once you get the data, how to take a decision making. It is not only for the farmers. I think the digital twins also has to be used for all the in the educational sectors, so that in the upcoming days, like the students should understand how the farming can be made, and at least the virtual simulation which will help them to understand it. It is like real time data which can be provided for them. And this is global smart agriculture market with the 19.32 billion in 2022, and it may reach to 48.766 billion in 2032 using the global smart agriculture market. Then this is a case study where Israel and a smart irrigation, where which is a country in the Middle East. Okay, we all know that it's a semi-arid region. Okay, geographically semi-arid, which makes farming very difficult at that time. Okay, so as a global leader, it started the smart agriculture, which implemented in the year 1960. Then a drip irrigation technology which delivers water slowly and directly to the plant roots, where improving the water efficiency in arid conditions was the first introduced by this country. Okay, so using that, they manage the precision drip irrigation, IoT sensor, AI and machine learning, drones and satellite imaging, GIS mapping, then the smart greenhouses, livestock monitoring system, then the desalinated or recycled water to achieve efficient and sustainable agriculture. So roughly now Israel produces around 4 to 5 million tons annually, which is a more production than the neighbors like Lebanon, Jordan. Okay, so everyone has to thank to the advanced irrigation and the smart farming. Even though where the countries have a larger or a smaller farmland, but lower yields due to the less efficient agriculture technology. So this is one of the case study. And one more case study is from the Shimoga based company, where the Krishi Hridaya, where they installed the borewell sensors in the farming. It is a Bangalore-based company, but it has been installed in the Shimoga area, in the borewell sensor. So what happens is here, see here, you can see this image here. So the motor will be, motor is been installed in the near the ground level water. Okay. So at that time, what happens is, suppose if the water level goes still down, and if you start on this, the borewell at that time, the motor gets, spoiled. And it has to be maintained. Again, it has to be taken, it has to take out, and the team has to come, and lots of work. The borewell maintenance work is not easier, so it has got a lot of work. So at that time, this team, the Krishi Hridaya team, they have implemented one, the sensor inside the motor, where it will identify whether, suppose if there is no water, then it should not on the motor should not on. So it gives the information saying that the water level is very low, and this is a patented product by them. So that this has been implemented by the Krishi Hridaya team. Then the disadvantage of the smart agriculture, we have seen all the advantages. High initial cost. So suppose if anyone has to implement this kind of the modern technologies, then investment is more. It is expensive because people have 10 acres, 15 acres land. So at that time, lots of IoT devices, sensors, it is required, and so cost is more. Then job losses and artificial labor. So again, in a country like India, again, which we say that in India, where people, they are looking for the jobs at that time. In this area, suppose if it is in agriculture area, they may lose jobs actually. Suppose if a human is being replaced by the drones at that moment, they may, lose the jobs, which can lead to the widespread unemployment among the farm workers. This is only for the farm workers who are very much interested in that at that time. Then the technical expertise requires. So suppose if the farmers uses all these things, the technical expertise required for this managing the sensors. Now suppose if there is a drone, how to fly the drone, there should be someone who can manage. If the farmer has the knowledge, then it is okay. Otherwise, again, we have to hire one more person. So that is called again the system maintenance is there. Then dependence on the internet and the power. So we know that most of the places there is a power cut, and then internet, which is where we get a low speed internet. So in such cases, again, this kind of system doesn't work. Then the maintenance and repair issues. So the sensor drones are automated machineries which breaks down. At that time, it requires again costly maintenance or the skilled technicians. Then data security and privacy risk. So storing farm data digitally may expose to hacking. So again, data security is required. That's why that time a word called as decentralized. Again, using a blockchain technology. Suppose if the data can be stored, then it can be secured. So since right now the data, it may be exposed, the normal text data which is being stored, or the images which has been stored in the cloud application, again that can be hacked. Suppose if prevention is not been, or the security is not been provided. Next one, the limited adaptability. Some smart systems are designed for specific crops or conditions and may not work well for all types of farming or climates. So what happens is some smart systems which is designed only for, suppose if it's only for the rice field or only for the corn, at that time it may not work for some other thing. So the limited adaptability also may be there. So he has to buy one more devices for that. Then environmental concerns. Overuse of technology can increase energy consumption, create electronic waste, or lead to over dependence on the artificial inputs. Suppose the power charging, the electrical charging, or something like that. So that also may be the one environmental concerns in this case. Then the security frameworks in smart agriculture. So all the data, this I want to explain. So what the data, like the soils data, then the crop data, animal, then the market and the management data, all these things are collected and all this stored in the cloud. Suppose if this data is not managed properly, or if this data is not being, not secured, then there is a possibility of the data leakage and the data storage. And this is a loss of the farmer privacy, one thing, and also it will may cause a financial loss. It may be cause a financial loss for a particular country also, because all this data and their every steps which has been managed in the particular the storage, that has to be kept very secretly. So moreover, if hackers can break into the farm's main system and tamper with smart equipment to alter the farm setup, they could disrupt irrigation schedules. Okay, suppose example, like if someone wants to take a revenge on some farmer. So again, suppose if you tamper with the smart equipment, the same drone can be used for some other purposes. So again, that is also this, and all the blames will come to the farmers. So again, misguided AI decisions damage crops and cause large financial losses and even threaten food security by bringing entire farming operations to a halt. So we coming to the end, we have the startup funding for agriculture. Okay, so the central government or the state government, these the government, they fund for the startups. So I know about the startup elevate program, which started by the Karnataka state government. Also, we have it in the Kerala government, also in the Maharashtra. I don't know anything about the other state governments, but I have heard about these state governments where they fund the elevate programs. The elevate programs in the sense, suppose if you have any plans, okay, like to implement any of this kind of IoT technologies or the drones or any of the modern technologies, where using your system, we can improve the crops, the quality of the crops, or like which where we can export more crops. So in that case, you can apply for this kind of the programs. One is a RKVY, which is called, that's called a Rashtriya Krishi Vikas Yojana and Agri Sure Fund. This has been managed by the central government. And one more is a state Elevate program, where they grant loans and incubations, where this is not a subsidy, or like it is I'm sorry. I'm talking about the Elevate program. Elevate programs are not the loans, or like not the subsidy. It is total amount. Maybe it starts from 20 lakhs to 50 lakhs, which is being provided only to that particular startup. Okay, suppose if you are good at pitching your ideas, then the entire 20 to 50 lakhs amount will be funded, that will be funded to you, and based on your pitch deck, and after that, based you can use that capital to build some kind of these kind of IoT technologies. And now in general, where the Rashtriya Krishi Vikas Yojana or Agri Sure Fund, where they grant loans and the incubations, and the private impact investors and the CSR funds, again the seed funding. Seed funding can be done through the private investors or the CSR funds, then targeting innovation in agri-tech, then food processing and supply chain solutions, then with support ranging from idea stage grants, where the starting from the 5 lakh. Suppose if you are depends upon the pitch deck again. So how much you are proposing, and it should be very realistic. Suppose if it is a 5 to 6 lakh, then you have to mention that. So 5 lakh will be provided to seed growth funding 25 lakh. So idea stage from the grants from 5 lakh to the seed growth, and 25 lakh for the R&D, prototyping, and then the market scaling. Okay. Then we have the key avenues include incubation support, direct investment, and a low-cost debt financing for the infrastructure. There is a training facilities. Okay, the incubation is being provided. Also, the training is also being provided from the government. They have the PDFs or the video materials, or few webinars which is happening. So to guide the startups. So the eligibility criteria is like it must be based and registered in India. So to suppose if you are applying for the startup fund, so it must be based and registered in India. Suppose if you are applying for the Karnataka state Elevate program, then it should be based in Karnataka. Suppose if you are applying for the Maharashtra state Elevate program, then it should be like the company should be based in Maharashtra. Okay. Then the early stage startups with the TRL 5 plus technology readiness level which you have. TRL 5 level, and a proof of concept means the initial what you call the prototype should be ready. If you have the ready prototype, then it is we can reach up to that technology readiness level, and then you should demonstrate that how it works. Then focus innovative technologies or solutions in agriculture and rural development sectors. Okay, so for the rural development sectors now, the governments are very much focused, and so it is anyone from the rural area. Suppose if they can build something, then there is very easier to get these funds. Then the target startups in the agri-rural ecosystem, including those supporting rural youth and farmers. So this is the end of the slide. So I just completed the innovations in the smart agriculture, which is a leverage machine learning, IoT, and the security frameworks based on my studies and my understanding. Okay. Thank you so much. I thank Department of Artificial Intelligence and Machine Learning, the Kendra College, for inviting me and to be a part of this program. Thank you.
Thank you very much, sir, for giving us such an insightful session. Your explanation regarding the different technologies involved in smart agriculture, and also you have given many more ideas regarding like smart startup involved, or maybe the case studies or real world examples. I hope it has been greatly beneficial, means it has we have greatly benefited from this, and also I hope this has been helped participants to understand more about the agriculture, smart agriculture. Thank you very much, sir, for such a wonderful session. Any questions
Thank you,
from
ma'am.
the
Thank you.
participant? I think we can wind up. Thank you, sir. Participants, stay on the line. We'll be having a valedictory soon. And soon after the valedictory, you can start with the assessment test. And it is mandatory to get 70% in the test.
Now we can't start the test, ma'am.
No, you have to start after the valedictory. Because same time will be used for all. So between 7 to 8, you can answer the test. And some instructions already are posted in the WhatsApp group about the test. So just go through it before answering. And also you should fill the feedback form. So only after successful completion of the test, as well as after filling the feedback form, you will be able to receive the certificate. Thank you.
Sujata madam, can we start a valedictory? Principal sir is also there and vice principal sir is also there. This meeting. Am I audible?
Yes, sir, you are audible.
Okay. We can start the valedictory.
So I welcome Principal of Canada Engineering College, Vice Principal, Vice Principal and Co-Coordinator of this ATAL online sponsored faculty development program on innovations in smart agriculture, leveraging machine learning, IoT and security frameworks, co-coordinated Emin Anthony de Mello. And also I welcome all the deans, heads of the departments, and faculty members, staffs, and dear participants. It was a wonderful FTP which spanned around for 6 days. and we had a very good sessions by different resource persons.
Let everyone
And
switch to the camera. This is a valedictory. I think. It is not a guest lecture. It is a valedictory. Let
If any network issues are there, the people can switch off their, video cam. Proceed, madam. Proceed.
yes, sir. So we had a very good resource persons for all these 6 days. So on the first day we had a session by Dr. Jaidar Sidi, that was on 5th of January. He delivered a session on machine learning for smart agriculture, recent trends and challenges. Followed by we had a session by Lingaraj Huggi, who delivered a session on machine learning and use of satellite wavebands in smart agriculture. And followed by there was a demonstration regarding extraction of satellite 2 spectral bands. And we had a next session on 6th January by Dr. Sunil Seki, who delivered session on machine learning and plant disease detection, followed by demo on use of labeling and processing of plant leaf images. And next we had a session by Dr. Jaidar Sid again on 7th of January, who discussed regarding how to use CNN in classification of soil fertility, followed by there was an explanation on practical implementation of 1D CNN in classification of soil fertility. And next we had a session by Dr. Vibhushani from Cardiff School of Technologies at Cardiff Metropolitan University, UK, who discussed about cyber security in IoT. And then on 4th day, we had a session by Dr. Chaminda Havaji from Cardiff School of Technologies, who delivered a talk on machine learning for cyber security assessment and mitigation. Followed by we had a very wonderful session by with the demo by Mr. Gopalakrishna Bhatt Kakunji, CEO and Managing Director of Kakunji Software Private Limited, who shared his expertise on how to use IoT in smart agriculture. And then on 5th day, we had a session by Dr. Gurraj HL from Manipal Institute of Technology, Bengaluru, who gave a session on IoT and cyber security for smart agriculture, along with innovations and issues. And followed by, we had a session by Mr. Tirupati, Chief Information Security Officer of SETS, Tamil Nadu, who delivered detailed explanation on different types of cyber security issues in smart agriculture. Along with, he gave a wonderful demonstration on security issues in using IoT devices. And then we had a session today. The beginning, we had a session by Dr. Rashmi R, who delivered session on the smart means the recent trends in smart agriculture. Followed by we had a session by Dr. Mallikarjun L on recent innovations in based on the soil science. And the last session was by Mr. Harish Nirmalga on innovations in smart agriculture on industrial perspective. So all these 6 days, we had a very wonderful sessions. I hope the participants have greatly benefited by the sessions. And on the first day, we had a inauguration by our chief guest was Dr. Prakash Raghavendra, and the principal was the president of the inaugural. And So inauguration also went very well, and I thank the ATAL AACT for giving us opportunity in organizing this ATAL sponsored online FDP, and also I thank management for giving us opportunity in organizing the workshop, organizing the FDP. And I thank Principal of Canada Engineering College for supporting us, and also Vice Principal, all faculty members, and mainly my co-colleague Stanley Pradeep D'Souza of ISC department for supporting me. So I request any of the participants to share your feedback on this workshop, on this FTP. Sorry.
Hello, I'm Dr. Vinayak from Srinivas Institute. Sir, the session was okay. I mean, it's there, but you would have perhaps roped in some more industry people. And one more thing is, you would have called somebody. I mean, you would have roped in somebody from Israel, sir, because Israel is very good in agriculture. You know, their drip system and other things and all. Even, I mean, they are good in a lot of things, defense, finance. You find everywhere. Uh, if we had people from there, because there, you know, it's a full desert and they have hardly any water resource are there, and they have come up with a lot of innovative in agriculture. And uh, there you would have got, I mean, if you have tried to check it with the Tel Aviv University or Winsman universities, I think you would have got even Nobel laureates also. I mean, the Israel is known as land of innovation. I think you may be knowing, I mean, knowing that. So perhaps I think one or two sessions by them would have been it have been wonderful impact, because they are known for the drip irrigation. It is there, and you know it's a land of landlocked country, and I mean surrounded by whole enemies. It is, and they're known for innovation. So, and or perhaps somebody from more from, and one more is more from the industries. If they are roped in, because one example is, I think Kukunje Software. Somebody has delivered a very good talk. Mr. Bhatt, I think he is alumni of Canada also. That is, his talk was very good. That stands out. And I think this what I felt from my side, sir. Overall, it was okay, but industry people, they deliver. I mean, hands-on, they'll deliver better. What I felt, and roping in some Israelis would have been better. What I felt there.
Thank you, sir, for your feedback. We'll consider your suggestions. Any other participants?
Good evening. Am I audible, ma'am?
Yes, you are audible, sir.
Yeah. Good evening, everyone. Myself, Dr. Rajesh Nayak from SMVITM Bantakal, Udupi. So, as far as my concern, the sessions were very good because it had a proper blend from academicians to industries. Even scientists were involved from agriculture department. Because for researchers, like when all these categories are included, we get more exposure, like what can be done. Even though we are doing some like projects related to, or yeah, related to agriculture and all, in these 6 days FDP, we got to know even that security aspects, because those things were something new for me personally when this agriculture domain is concerned, because I never thought about this, like cyber attacks related to the IoT devices included in agriculture part and all. So those things were new. And yeah, all speakers were having very good domain knowledge and everyone has delivered their best. So I thank Sujata ma'am and all those who are concerned with this FDP, vice principal, even HOD of AIML and entire Canada Engineering College for providing all of us the opportunity to be a part of this wonderful 6 days FTP. Thank you.
Thank you, sir, for your valuable feedback. Any other participants? I now request Principal of Canberra Engineering College to speak a few words.
Good evening, everybody. Respected Vice Principal and Co-Coordinator of this FTP and HOD of ML Department, Dr. Vasappa K, and the Coordinator of the 6-day FDP, Dr. Sujata, Deans, HODs, and faculty members of Canberra Engineering College, and my dear participants. So I hope all of you have enjoyed the 6-day FDP in terms of different verticals. As one of the participants has rightly mentioned, he has got a blend of academicians, then industry, then research institutes. Because in a 6-day FDP, whatever the content that could be covered, so some of the verticals we can just, as organizers, we can just show the path for the participants. And it is for the participants to go in that path and explore themselves. Because innovations, it requires a lot of blend. Because when we invite only people from the industry, they may talk about only the implementation of the technology. But when you have academicians, they really talk about developing the analytical models or any model that could be developed, the algorithms that could be developed, or some of the security mechanism that could be developed for tackling the security issues in case of smart agriculture or especially in the Internet of Things. So I hope all of them have really enjoyed this 6-day FDP. At the outset, I thank the management of Kendra Engineering College, that is management or management of Kendra High School Association. Special thanks to our Honorary Secretary, Mr. M. Rangnath Bhatt, who supports in all the activities we conduct in our institute. And I also take this opportunity to congratulate the Department of Artificial Intelligence and Machine Learning headed by Dr. Basappa K, who has successfully materialized conduction of this 6-day FDP and applied and got funding from the AICT and the coordinator and co-coordinators. I congratulate all the whole team behind this 6-day FDP on innovations in smart agriculture. And you made even then, because conducting or organizing an online FDP, it has got its own challenges. In spite of that, you made it possible. Once again, I congratulate the whole team of CEC who are involved in successful organization of this 6-day FDP. And I also thank the management and principal of all the participating institutes where they have sponsored the participants to attend this FTP. And with that, I conclude my address. Thank you.
Thank you, sir. I request Basappa sir, Dr. Basappa BK, HOD of Animal Department, to speak a few words.
Good evening, everyone. Respected Principal Sir, Vice Principal Sir, Deans, HODs, and all the participants across India. So when we started publishing this, FDP, we receive lot of requests from various parts of India. We received more than 325 participants registered to this workshop, and out of which more than 275 participants have turned. It's a very good response, and definitely the participants might have taken positive inputs, and they definitely will take those insights of this FDP and apply into their research and innovation. I must thank the AICTE. They sponsored this FTP and encouraged all the faculty across India to enhance their skill set, and also those skill set can be disseminated to students and wherever they are working. And also I must thank the management, principal sir and vice principal sir, and all the people who have helped in organizing this faculty development program. That's all from my side. Thank you.
Thank you, sir. So I thank, finally, I thank the management for giving this opportunity, and also AICT ATAL for sponsoring to conduct this FTP. And I thank all the faculty members, deans, HODs, and all the staffs and faculties of Canara Engineering College, and all the participants without whom this FDP would have never been successful. So I thank all the participants for registering for this FDP and participating in the FDP. So we had around 250 successful participations. So without the registration of participants and participation, it would never have been successful. Thank you, Anand.
Thank you, Anandal. Thank you, Sujata madam.
Thank
Thank you,
you. Thank
Basava
you.
sir. Thank you, Deming sir,
Thank
and
you
the
so
whole
much, sir.
team of CEC. Thank you, Anandal.
Thank you, sir.
Thank you, sir.
Thank you very much.
Thank you, sir.
Now all
Thank you, sir.
participants can, now all participants can take a assessment test from the
Assessment test.
AICTE portal, ATAL portal.
Already I posted in a WhatsApp group the instructions to take the assessment test, and also a video link has been posted. So if you want if you are unaware about how to how to go about it, so you can use that, refer that video before starting the test. And once you start this test, you have to you cannot leave the test in between. So you have to complete the test and then you can leave. And there will be 20 questions and duration of the test will be 1 hour. So within 1 hour you have to complete the test. So between 7 to 8 you can complete the test. And soon after completing the test, please fill the feedback form, which is again available in the ATAL portal. So again, the instruction to make use of the feedback link is also posted in the WhatsApp group. So there won't be any separate Google form today. So please use your ATAL credentials.
Madam,
And
within 8 o'clock we have to take, is it? Or we can take little later? Because I have some.
Between 7 to 8.
No, within 8 o'clock we have to take, is it? Or we can take little later, I'm asking. Is it up till today night its time is there? Because I have. Or within 8.
Before what time you can complete, sir?
Because actually tomorrow my mother's ceremony is there. I have to take some things. So I thought I will take after 8 because after the shop gets closed.
In 10 minutes you can complete actually. So if you have attended the sessions, it is not difficult. It is a very easy assessment.
It's a
test.
MCQ, right?
No,
It's a
simple
MCQ, right?
MCQs. MCQ, yes.
That's what. Okay. No, because I have to take some things or else I would have done it. Because no, up to what time the test time is there to take? Is it okay by 9 or 10? I will take it and this thing. Is it okay? Within 9 I take.
Okay, sir. Between 7 to 9 then. But
Yeah,
you will be
please,
given
please,
only
madam.
1 hour. Once you start,
No, that's what.
within 1 hour
That's
you
not a
have to
problem. Yeah, sure.
complete.
I'll finish within that, madam, because That's what.
Questions not
Okay, thank you.
submitted, it is coming.
What, sir?
Questions not submitted. When I'm going to start the assessment,
No, it is already submitted, sir.
oh, I can't able to.
I'm facing the same issue, sir. Questions
I
not
will check
submitted.
it.
It's coming like this.
Issues are here.
I will check it, sir. Before 7 minutes.
Okay, okay. Thank you, madam. Thank you.
Ma'am, please tell us something about reflective journal. Is it mandatory?
Yes, sir.
That is
Without
only.
which you will not get your certificate will not get generated. So both test as well as feedback is mandatory.
Ma'am, but
For
you
reflective
communicated in the
journal.
group that only offline participants should give it.
A reflection journal. So that is actually in my portal there is a link to upload. Even I am not sure whether it is mandatory or not.
Ma'am,
Oh,
actually for online it is mandatory. Sorry, offline it is mandatory.
offline it is mandatory. Correct, correct.
I
Somebody
don't
was
know,
typing.
madam, because
It is
in case
mandatory.
tomorrow
Yes,
they
Just
ask
for
me
sitting
offline it is
in
mandatory.
in my portal
No,
there
what
is a
exactly?
link. That's why I shared.
Okay, madam, what exactly we have to do that reflection journal?
Whatever outcome you have gained from the different sessions.
Okay, this IoT in
And
agriculture workshop, whatever outcome we have gained, we have to just write it in 3-4 sentences, is it? Okay,
yes.
okay, fine, fine. That's not an issue.
The
I was
one
worried. What is this
Hello,
general?
hello, ma'am.
Handwritten also fine. You can scan it and send.
The
Okay,
one
handwritten
what?
is also okay. Fine, fine, fine. Okay.
Yes.
Hello, ma'am.
Scan,
I'll take,
scan
madam, I'll
mandatory
take
or,
after 8, madam. It's okay, right?
Yes, sir.
Hello, ma'am.
Sujata, madam, I'll take after 8.
Yes.
Okay, okay. Thank
Okay,
you.
fine,
Thank you
sir.
very much.
yeah,
Yeah,
excuse
yeah.
me.
Hello, ma'am.
Is
Yes.
scanning
Hello.
the
Ma'am.
write up is or we can write printed. We can type it and send.
Anything is fine.
For reflect-
Either printed or scanned copy also fine.
Okay, okay. For reflection, typing also is fine. Okay then.
Yes.
Yeah, thank you.
At what time we have to submit reflective journal, madam? Reflection journal.
Yes, by tomorrow if you submit it, sir, fine. By tomorrow end of the day.
Okay.
Thank you. I will check with that problem and
Any
I'll put
questions
a
are not
message.
submitted in the ATAL portal, ma'am?
I have submitted. I will check what is the issue.
Maybe the time which starts from 7 o'clock, I guess, madam.
Maybe. No, but
Ma'am, during the test, we should stay in this group or we can exit and we can write because there's a no tab should be opened.
you can
rather than.
exit, sir. You can exit. You
Oh,
can
okay.
leave the group.
Ma'am, please confirm about that reflective journal, whether it is mandatory or not. As
I
we
will
attend
not
the
make it
FDP
mandatory,
online,
but better to submit because tomorrow, if it is mandatory, it might be a problem. There is no
Okay, ma'am.
information from ATAL. Thank you.
Okay.
Thank you, sir. We can leave the session.
Still the questions are not available in the portal.
Yes, madam, maybe it is not submitted properly. Kindly check.
The same issue is repeating, madam.
Hello. Hello.
Shall we wait for some more minute, madam?
Hello.